Hello everyone and welcome to this lesson on the derivatives of logarithmic functions. Today we are going to unlock the rules for differentiating logs and you will see that they are surprisingly straightforward. By the end of this, you will be able to find the derivative of any logarithmic function with confidence. So let's get started. So part 1, what is logarithmic function? So first, a quick refresher. A logarithmic function is an inverse of an exponential function. So the most important logarithm for calculus is the natural logarithm, which has the base e. We write it as ln x. So the key thing to remember is this inverse relationship. If y equals to ln x, that is equivalent to saying e to the power of y equals to x. They are the same. So these two functions on each other, the relationship e to the power of ln x equals to e will be the secret weapon in our derivation later on. So to your notes, write down this. The key concept: 1, the natural logarithm ln x is the inverse of x, so that let's get to part 2. The derivative of ln x. Now for the main event, what is the derivative of ln x? The result is beautifully simple. The derivative of the natural logarithm of x is 1 over x. The rule is let's prove why this is true. We will use a technique called implicit implicit differentiation. And that inverse relationship we just talked about. So let's get started. The step 1, we started with our function. Let's make the y equals to ln x. So the step 2, this is the key step. So let's use the red pen. The key step. We rewrite this in its exponential function. So that means, so the step 3, now we differentiation both sides of this equation with respect to x. The derivative of the left side ey with respect to x requires the chain rule. So it's ey multiplied by dy, dx. this derivative of the right side, x, is just 1. So now we solve the dy divided by dx, which is that we are looking for. This one is step 4. So the step 5, finally we substitute back. We know from step 1 that the y equals to ln x. So e to the power of y. And because of they are inverse, so it's just x. And there we have it. The derivative is x 1 over x. To your notes, please box the rule. It's one of the most important ones. That is the key rule. So let's get started to part 3. The general rule. For log a x. Okay. So what about logarithm with other bases like base 10 or base 2 or something else numbers? How do we differentiate log with some number x? So the strategy is brilliant. We use the change of the base. We use the change of base formula to turn any logarithm into a natural logarithm, which we know how to handle. The change of base formula tells us this is the formula. So now look at the right side. Line A is a constant. The right side, sorry. This one is constant. It's just a number. So log is really just a constant multiple of line x. So let's differentiate it. Let y equals to log 8x and line x divided by line a. Now 1 over line a is a constant. This one is a constant, so it just stays out front. We just learned from before that this one is equals to 1 over x. So and that's our general rule. The general rule, you can take a note here, the general rule. So let's do a quick sense check. If a base A is a number E. What happened to line E? Equals to 1. And the rule becomes 1 over x, which is exactly our rule for line x. Let's check out. And this is general rule to your notes. So the part 4, let's work through an example. Now let's put it all together with an example. Find the derivative of the fx. This is our question. So now I will tell you the solution of it. The first term, this term. The 5 is a constant multiple, so it stays. The derivative of line x is 1. Derivative is 1 over x. So the derivative of the first term is this one. The second term, here, the base is 2. This is the first term. The second term. The base is 2. A is 2. So use our general rule. This is a constant, so we are down. So therefore, the derivative of the entire function is we can even factor out the 1 over x if we want. So that's the final answer. So the summary, part 4 is our summary. Part 5, sorry. Summary. We learned 2 rules. First one is the second one is general rule. So let's recap what we learned today. The derivative of the natural logarithm ln x is simply 1 over x. Okay, so for a logarithm with any other base a, the derivative is 1 over x ln a. These rules are powerful tools that you will use again and again in calculus. Remember the journey we used the definition of the logarithm and implicit differentiation to discover these rules. Thank you for watching. If you found this video helpful, please give a like and subscribe for more calculus lesson. Happy studying!